Okay, look at this question now. A system of two dipoles plays in the way as shown in figure. Two dipoles means what? Plus q and minus q. So this is your one dipole, and minus q and plus q, this is your sorry, this dipole is upwards and this dipole is downwards. They are placed such that they form a square of side A. So there are four options given. We have to check which option is correct. So option A says that it is possible to consider a spherical surface of radius A whose center lies within the square shown with total flux positive. Option B is saying the same thing with total flux negative. Option C is saying the same thing with total flux 0. So we have to draw a sphere over here. So let's draw the sphere. Okay, this is the sphere over here. Okay, this is the sphere whose center is at the center of the square. And as you can see, since the sphere does not enclose any charge, so total flux through the sphere should be 0 according to Gauss law. So option C will be correct. Now let's look at option D. There are 2 points within the square at which electric field is 0. Okay, let's see. So one thing we know about dipole, that for a dipole, the electric field on the equatorial plane is what? It is opposite to dipole, correct? So if I draw the equatorial plane, so if I draw the equatorial plane over here, okay, this dipole is pointing upwards, so it will create electric field in downward direction. Okay. Similarly, this dipole is pointing downwards, so it will create electric field in upward direction. Okay. But since this point is closer to this dipole, the downward field will be greater than upward field. So over here, field can never be zero. Similarly, if I take a point over here, because of this dipole, the upward field will be more than the downward field created by this dipole, correct? So over here also field can never be zero, but at the center it will be zero. At the center field will be zero. You could say that this q is creating field in this direction, this q is creating field in this direction. They cancel each other. Similarly, these two charges create opposite fields, so they cancel each other. Okay, and along this path, everywhere at this point before the center, field created by this charge will be stronger as compared to this charge. So over here net field can never be zero. Over here also net field can never be zero. Similarly, over here net field will never be zero. Here also net field will never be zero. So basically, if you think about, there are many points in the sphere, and nowhere the field will be zero. The field will be zero only at the center. So this option will be again wrong. Okay. So the answer is option C.